Now we are going to try out the linear combination of atomic orbitals, that is our LCAO. Right. So what does it, the LCAO actually wants to state? It is actually a theory which explains the combination of atomic orbitals. So according to this theory, what we have is that suppose if I need to form a hydrogen molecule, right, if I need to form a hydrogen molecule, so let's say this hydrogen molecule is formed by the combination of two atomic orbitals, one HA and one HB. HA has a wave function xi A, and let's say that HB has a wave function xi B. So when they are going to combine, what is going to happen? So that means either of combination can take place, either their wave functions may add up or their wave functions may subtract up, right. So if their wave functions add up, it is going to form an orbital which is called as bonding molecular orbital. And if their wave functions subtract up, so it is said to be xi star, that is anti-bonding molecular orbital, right. So that means according to linear combination of atomic orbitals, the xi can be added, xi of atomic orbitals can be added, or xi of atomic orbitals can be subtracted from each other, right. And we need to know that like if what happens actually, see in bonding molecular orbital, when the wave functions are just adding up, right. So here what we see, like I will draw an example, suppose this, and here I am going to add up, and as a result I get this kind of structure. So now it says actually that electron density in bonding molecular orbital, so this is my bonding because I have added up, right, is between the nuclei of bonded atoms. So that means this is my nuclei, this is my nuclei, I will just remove this circle, right, because this circle was just indicating the positive sign. So here the nucleus are just adding up, right. So what happens here, the repulsion between these two nuclei are comparatively less because this space is actually filled up by the electrons. So that means electron density in bonding molecular orbital is between nuclei of the bonded atoms. So that's why the repulsion between nuclei is less. But when we talk of anti-bonding, so let's draw first anti-bonding one. So this is the nucleus, I need to subtract it, right. So after subtraction what I am going to get? I am going to get a cloud like this. This is my nodal plane. So it says that in anti-bonding the repulsion between nuclei is high, as you can see that electrons have just moved away from each other and they are the nucleus which are facing towards each other. So that means there is more repulsion between the nuclei, that means it is comparatively unstable. So the second thing is that, like I think if you are familiar that what actually is LCAO theory, it is just trying to explain us that when we are adding the atomic orbitals, they may add up or they may subtract up, and likewise accordingly they will give rise to bonding or anti-bonding molecular orbital. And what is the reason that anti-bonding is less stable and bonding is stable? I think it's clear, because in anti-bonding the repulsion is high, but in the bonding repulsions are comparatively less, right. Now what are the conditions actually required when the atomic orbitals combine with each other? So the condition is that, first is that the atomic orbitals should possess same energies. Atomic orbitals must possess the same energies. Like you can combine or you can say S with the S, but you cannot combine S with 2pZ, right, because the internuclear axis is even different and even the energy difference is quite high. And likewise when we are selecting the atomic orbitals for the combination, they should have the same symmetry. They should have the same symmetry, that means they should be symmetrical around internuclear axis. Like I can combine this S orbital with this kind of orbital, but I cannot combine this S orbital with this orbital because its internuclear axis is something different from this, right. So they need to be symmetrical actually, they need to have same symmetry. And even we know that like if you want a strong bond, so that means the overlapping region should be maximum, because more is the overlapping, stronger is the bond formed, right. So these are the three conditions which you need to keep in mind when you are drawing, when you are just trying to make a molecular orbital as a result of the combination of atomic orbitals. So this is what we need to do. Now I think it's clear that when we are indicating this thing, the bonding and the anti-bonding, which has the lower energy or which has the high energy, it is just you have to remember that bonding possess the less energy and anti-bonding possess the high energy, and likewise their stability, that means the bonding is more stable and anti-bonding is less stable, right. So this is our LCAO theory.